Hello, welcome back to Retro Ginger. So today we're going to be looking at some BBC micro performance testing. We're going to be using the BBC Basic editor and IDE on the PC, which is really amazing. Fantastic stuff, and it gives you a nice easy way of developing stuff for the BBC Micro and indeed other platforms. But today we're going to look at some of the performance tweaks we can do within BBC. So in the recent work in developing some games and some applications, I've been looking at how you can squeeze every last bite of performance, cycle of performance out of the BBC Basic language. So if I open up some tests that I've been working on, so here we have various tests for conditionals and for constants versus variables in loops and things like that. So we'll go through those in more detail. In the first instance, let's take a look at this, which compares two different types of if statements, specifically ifs with ands. If you have a statement with if something and something, then something, that's fine. It's logical, it reads well, it's easy on the eye, that's fine. But there is a performance benefit to be gained by having if, then if, which is exactly the same as and, logically, but you get a significant performance increase. So in order to make this easy to test both on a PC and on a BBC Micro, I'm using an emulator here, is I do a little bit of detection at the top. It's a little crude, but it's an easy way of showing the top memory. So if you do a print top, then it will show you the top of memory, that's a value that's never going to be anywhere near what a BBC Micro has. A BBC B returns about, I think, 6,200, which is a lot less than that. So by default, it's going to be a BBC. If it detects that it's not, then it will set a Q value to a higher value. In this case, it defines the number of times it iterates around this loop. So if I run that, it gives you a nice little test of the timing difference between doing a bunch of nested and conditions in an if versus a then if. So you can see here there's a significant increase in performance. So if we then take that data, take that program, boot up a BeebM, which is my favorite BBC emulator by far. I'd love the fact you can just paste the code straight in, really easy, and then run that, do exactly the same tests on a BBC, emulated BBC, and then we can compare and contrast the results. It'll take a few minutes, well, not a few minutes, it'll take a few moments. It's not that slow. Needs to be some elevator music or hold music at this point, but I'll sort that out. Did I set the Q value too high? Oh, there we go. The longer you have those tests, the more cycles you have, the better you can do a fair comparison. When I was developing this stuff, if you have the Q value too low, then really it's difficult to do the comparisons. The more cycles you have, the easier you can pull out those differences. So you can see a difference there, obviously, between the PC version and the BBC emulated version. You could mess around with the Q value, but you get the idea. The idea here is to illustrate the fact there's a significant improvement in performance you can gain from converting your ands into a then if. I'll put that in the description. So another test here is a variable test. So it will test loops comparing integers, variable integers and floats. It will also test whether checking a variable conditional versus a constant has a performance benefit as well. So if I run that on a PC, so you can see here you've got a loop with a float value, with an integer value, i.e. if you've declared it with a % sign, is a lot quicker. So that definitely do that. Uses less memory and it's quicker. Okay, sure what that one is. Loop with I wrote this, but I'm not sure what it is. Loop with integer without next var. Yeah, okay. So another strange thing. So in here you have a loop which says for x% equals 1 to q. The q value we set up there. So next x%. There's a difference between that and that. That doesn't have the x%. It's the same code, exactly the same, but it doesn't have the x%. And you get a difference. You get a performance benefit in not saying it, because if you specify a variable, then the basic interpreter has to go and figure out what that means, whereas it knows what scope it's in already. So as long as it's properly nested, which it should be if it's a for loop, then it will just default to the current scope. If it wasn't defaulted to the current scope, you get weird behavior anyway. So it's kind of you should never really have in for loops and nested for loops a variable. You don't need it. Next one is something else. Oh yes, that's actually a little bit unfair. That actually, yeah, okay, let's come back to that. I need to rework. I've just noticed something strange with that one. And the last one here is conditional by constant and by variable. So if you're checking by a constant value versus checking by a variable, there is a very slight performance benefit to be had by checking from a variable from a variable. So if we then add some numbers to that, we're going to blap that out of the BBC, paste this in, and that should become clearer on BBC. Okay, so running through those. So a similar kind of pattern, significant increase with the use of integers. Now this might be interesting, so let's have a look at this. So conditional by constant versus conditional by variable. So there is actually quite a difference. There was only two there. Maybe the q value is set a bit too low. But in here you can see a significant difference. Now it might not look much, but if you're talking about a large number of iterations, nested loops and whatnot, then it can make a significant difference. So I'm going to write these up and put them in a little in the description, and there will be more. As doing this investigation, I've discovered a number of little funny little quirks and workarounds and optimizations. These are the main ones, and they can really benefit your BBC code, both running on Windows, on mobile, or whatever you like for the BBC Basic itself, but especially on a BBC Micro, where, you know, even though it's a blindingly fast Basic compared to most desktop, most 8-bit machines, it still has limitations. You know, it's a 2 megahertz system, and needs all the help it can get. Anyway, that's enough for now, and I'll see you in the next video. Cheers.